Hi everyone, are you able to hear me clearly and see my screen clearly? Great. Great to have all of you in the session. All right, so there is a question from Bidao. The question is there a special project for us to earn the certificate available now? So the way the certificate would be given is based on the final project. But what we're planning is just like the way we are doing one end-to-end project, we have identified 3 more projects similar to this one, where you can basically do all the steps that we are doing here on a different data set. So that particular project will be given at the once this project gets over, and where we'll form a group of two people, and you will have to follow the similar steps, or you follow the similar strategy to understand and explore data. All right, so that will happen after this gets over. There is an echo. Is there an echo? Let me just, I see, because it's not picking up my, okay, this should be better. All right, so is there still echo in the voice? Wonderful. Great. Great. All right, so let me just walk you through what we have gone through so far. We'll just try to do it in like 2 minutes. Okay. So I'm going to do from the beginning. Okay. So we started with an end-to-end project. Right now we are working on an end-to-end machine learning project. So we checked out and we set up our environment, and then these are the steps that we're going to follow. So we're going to frame the problem, look at the big picture, get the data, explore the data for gaining insights, and prepare the data for machine learning algorithms. Then this is where we are right now. We are going to follow these, but till here there has been a lot of things that we have learned. Okay, so the purpose was to build the model for housing prices. Again, let's recap. This is important. So what we want to do is we would like to prepare a model which can predict the housing prices in California given the data about a district, about a block. So so this is how it looks like. And for us, the data was located in our GitHub repository, so we were able to load it from there. Okay. Okay. So the first purpose was okay. And all right. So this is where we were. Now moving ahead. So this is the objective, and again we drill down the business objective further clearly, and we understood that our model is going to sit in some data pipeline. Okay, And we understood the current solution clearly, and understood the current error rate. Then we identified the type of problem. Then it was basically supervised regression task. And should we use batch or online? So we settled down for batch. And then we understood the basics of the analytics. What is the root mean square error? We talked about various kinds of variables. Then the we talked about what is a probability, and we we went ahead with the calculating basic ones. Then we talked about the probability distribution, and we talked about the modality in probability distribution. We talked about box plot to understand the uh, to represent something called interquartile range. Okay, then we talked about how to define the center. We could define mean, median, mode. We discussed that median is stable. In a case of larger statistics, median is stable. And then we talked about the measures of spread, and measures of spread is variance. And moving ahead, and we figured out, we learned about something called normal distribution, that there's a formula that people realize that could represent most of the data set. And the equation looks like this, and most of the systems have a inbuilt library for doing this. So we learned that part. We also understood that in case of bell-shaped curve, the the total number of records, or total number of amount of data, or or the percentage of total data is within the first within the first three standard deviations. Okay, so we talked about comparing the two uh, comparing the two different results. And as we will study further, this will come into use. So whenever we are trying to compare the two different scoring, what we do is we first find out the mean standard deviation, and then we figured out how many percentage, how far is how many standard deviation away is a particular value. So we subtract the value from the standard deviation, and we subtract the value from the mean divided by standard deviation, so we get a number. Okay, so this we will use further when we compare multiple algorithms performance, and you will get the clear idea at that point of time. Okay, a question from Nirav is, how can we identify which model is perfect for particular analysis? We will learn that. Okay, we will learn that, and as we go ahead. A question from Kamal, does left skewed mean there's a significant more data on the left? Yes. Significant more data on the left is what it means. All right. Now, great. Then we talked about we talked about finding the best fit. So since it's a regression problem, we try to define what is a regression. That regression problem is, if it's a linear regression with a single variable, it's called single variate linear regression. Okay, what is linear regression? Given the data points, we try to draw a linear line, straight line, and that's called linear regression. We think that our data is going to fit a line, and we measure the performance by between the actual and the points at the line, and by this kind of a formula. This is called the error, the root mean square error. Okay, so what we learned was that in case of regression, we basically try all kinds of lines and and computing W0 and W1 in case of a linear regression, W1 and W2, as in the slope of this line. Slope of this line is W1. The slope at which the line is bent, and how far is it from the center, whether it's here with the same slope. That's W0. Okay, so this line is represented by these two numbers, how much slope it is and how far it is from center, and these W0 and W1 is what basically we call our model. In case of linear regression, these two is what represent our machine learning model. Okay, so then this was the basic introduction of linear regression, and moving ahead, and then we talked about something called getting the data. This we did already, and then we took a quick look at the data, and we figured out that there are total 10 attributes. Some of these are categorical, some of these are numerical, and so on, right? So then what we did was we plotted a histogram of the data. What is a histogram? On the y-axis, it is the frequency of, on the y-axis, it is the total number of observations, and on x-axis, it's the actual data. So if you look at this data, it shows that let's just take this one. So the total number of observations where median income is 4 is 1400. Okay, when the median income is little lesser than 4, which is maybe 3, the total number of observations are 1600. So this is what a histogram shows. Histogram plots the total number of observations on the y-axis against every value. Okay, so for every column, we can plot the histogram easily and take a look at the data. Right now, we just plotted one column here, the median income. This one, we just plotted this one just to understand the observations. Okay, and though it's a bell-shaped curve, but suddenly there is something on the right-hand side, and that when we discussed. Okay, so what is the unit of income? I think it is some in thousand something. I think it's I think it is 1,000 per month, $1,000 per month. Okay, I think it is that. The median income looks like in US dollars. It's okay. Okay. All right. Now going back. So we realize the data is capped, meaning there is, when we observe a histograms generally show a lot of things about our data, right? If the histogram doesn't look like bell-shaped curve, it looks like a straight line, like this one, that observations at every point are equal. That generally shows a very artificial process, not natural process, because in nature, more number of observations will be found in the average. Okay, so here we realize the data is capped, and that data is capped in many values, including the house median values, house median age, and the median house value. Everywhere data is capped, as in these number of records that you see, because on y-axis it's number of records. So there are more than 1,200, probably 1,300 here, 1,300 records just at 51, right? That shows that there's something wrong with the data, right? And what is wrong probably? All the values after 50, all the values that were supposed to come after 50, they have been capped at 50. Okay, they have been set as 50. Therefore, the line that could have been gone horizontal has gone vertical. Okay, so the total number of observations have increased for 50 instead of being on 51, 52, 53, 54, and so on. Okay, same thing is true for this one. All right, so this means the data is capped. So we'll keep this in mind when we do other observations and when we try to when we try to manipulate this data. So far what we have done is we have plotted that, we have understood the number of columns, we have drawn the histogram using function called hist, and the whole table is represented as a data frame, and where we can process either the whole data frame or individual columns easily. Now, all right, so good, good. Now these are tail heavy histograms, and we will basically try to reshape them as we go ahead, and we learn how to reshape them, as in if there is just big tail, we'll try to move this data to this side and make a smaller tail, because if the tail is really big, as in there are too high numbers here, it's going to hurt our general plot, right? If you take a look at this, just because of tail, because there is some data here, one or two records, the whole histogram is shrunk to this point. Okay, so it won't give us a fair amount of idea about our data. So we'll try to either cap this or move this to the left. Maybe we divide it by some number and so on. Okay, so we will learn those parts. Now, the other important part, the first thing that we do after observing our data is breaking the data set into two parts, training and test. Okay, and what we'll do is we'll do a random sampling, and ideally training set contains 80% of the data and test contains 20%. So when most of the problems associated with machine learning, specifically supervised, need to be tested, right? Most of the supervised learning algorithms are about prediction, right? We predict the outcome. So the way we predict the outcome is by breaking the data in two parts, building our building our model based on one set, and whatever model comes out, we test it on the test set. Okay, so and we should separate this training test and test set as early as possible. Why? Because we could snoop at the data and we could try to fit our model to the data, right? And the overfitting or underfitting could happen. All right. So these are function available from scikit-learn, which takes the ratio and the actual data, and it breaks down the data set into two parts. That's what we learned earlier. And what it does internally is this kind of work, okay, that we showed. And we also talked about that the data set that is, we also talked about something important, that we make sure that the data is not always random. On every run, across every run, the training set and test set should be same. Okay, otherwise our model could end up looking at the entire data set in the longer run and would be able to do predictions based on the actual values, right? Instead of based on the model. So that's why we kind of define a random seed. Now the next thing we did was we tried to further fix the splitting of data by using a columns value and instead of absolutely random. All right. So then we talked about this particular approach. It's for the cases where um, the records are continuously being added or updated. Because in case records are being added or updated, the random function, even if we fix the seed, would result in an entirely different data set. Okay. Therefore, we talked about this approach. Now, this is what we talked about, and we basically used latitude and longitudes combination to pick a record or not to pick a record for training and test. Okay, so that's what we learned earlier. Then we talked about something very important called sampling bias. Okay, so sampling bias is something really important. Sampling bias is if the data set is sampling bias comes into place that the minorities in your data could get ignored. Okay, minorities could get ignored if we just pick a random sample. Okay, that's like, for example, if we are say conducting a survey and there is minority, as in the people who are not available for giving the survey so quickly, your model, your survey could 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 ignore them completely. Therefore, what you do is we basically do various other kind of sampling or survey. Okay, so sampling must be representative of the whole population, not the partial partial one. Okay, and there were various biases we talked about, and we talked about various sampling methods, and out of this sampling method, the best method for sampling is generally considered stratified sampling, whereby we create something on stratas, meaning we create a column in our data with these values, different like 5 6 values, and we basically keep we create the strata such that the minorities don't get ignored. They are part of one of the stratas. Okay, so in our case what we did was we created the strata based on the income. Okay, so that while we pick the sample from the whole, the people having uh, income which is outlier should not get ignored. Either very high income or very low income, their records should not be skipped. That's why what we did was we broke down our data into five median income ranges. Okay, so we looked at this housing median column, and we found that it looks like uh, there's a there's a big tail on this side, and what we did was we converted this into 5 buckets. Okay, and so this is what we did. We first of all shrank the whole range by 1.5, and then we using ceiling we basically rounded the number to the next bigger, meaning 1.5 became 2, 1.1 became 2, and so on. And once that was done, we also kept our data. We kept our data using this mechanism. If the categories value is greater than 5, then we set it to 5. Okay, and after this, our data looks like this. So our category, this is the column called income category. Its value goes from 1. It has 5 possible values: 1, 2, 3, 4, 5. Okay, and now we have got you can say 5 categories or 5 stratas, and that's how. Okay, so Tanmay's question is, how do we decide about 1.5? How did we decide about 1.5? Because we had thought that maybe we'll just keep 5 categories. Okay, we thought that we will just create 5 categories. You could create 6 categories or maybe more, and that's why we basically divided the data by 1.5, right? Because our data looks like it's going to 9 or 10. So we just divided the data by 1.5 so that it could come till 5. Okay. And say up to here is our most of the data. So if we divide 9 by 1.5, it'll become 5 or 6. Yes. It should depend on your data and scenarios. But what you do is, the important part to understand is that we should not have too many stratas, and each stratum should be large enough. All right. So that's why you should always define your stratum. Then that's the key thumb rule of defining a stratum. Now, by using the simplistic way of breaking it down into stratas, we figured out that it is good enough. It kind of looks like a bell-shaped one, and there are too many stratas, and each strata has good number of records. All right. So for once we have created the stratified records, then we can use the stratified shuffle split class from scikit-learn in order to break down our records into testing and training based on a particular column. So if we first define this stratified shuffle class here, we are defining an object of this one called split, and then on a split we are calling we are calling a split function to which we are giving the total data set, and we are giving the column on which we want the data set to be sampled. Okay, so this is basically causing the stratified sampling. Now, once that's done, we have got stratified train set and stratified test set. And then we tested whether it worked or not. So what we did was we compared the results. We compared the results within each strata by using the by comparing the general randomized sampling and stratified sampling, and we found that the records it has actually worked because there were less errors, in case of stratified sampling. So you can see that it has 5% error. The stratified sampling had very small error. Okay, so we compared how we basically compared the values from both the stratas, and we figured out the differences in the we figured out the differences in the values, and that's how. Okay. All right. So yeah. So what we did was we did the value counts for each of the categories in both the sides using the normal splitting, as well as using the using the normal splitting, as in this random splitting, as well as the stratified splitting, and we did the value counts in the whole data and see in each bucket how many values are there in both the ones, and then we did divide that to total number of values by total number of records, and that's why we figured out that what percentage of data went in each category. Okay, and then we compared that. Did it end up doing wrong, or was it closer to what we had thought? So it showed clearly that random one ended up giving us more than 5% of error. All right. So the ratio of total records in each bucket is what we have counted. All right. All right. So that's how we created the stratified sample records. Okay, Gopi, if you are doing stratified sampling, you have opened that notebook, what you have to do is you have to run all the cells till that point. Okay, so select the cell, click on the cell, and then go to the menu and say run all above. Then it will work fine. Okay, and it's okay to share the question with everybody. All right, because probably others are also facing the same problem, and that should be good. All right, so sure, Vinta, no worries, no worries. We will be posting that one. Of course, that's the direction we have to go. Great. So this is what we learned, and then we started visualizing the data. We did this is how we tried to plot the data using the scatter plot, and you can see that we basically made each of the dot transparent, as in translucent, and based on so that we could see the density as well as the pricing at every point. so uh, so we were able to plot this kind of a graph whereby it looks like a geographical map. Why? Because we have plotted latitude versus longitude, and also what we did was we made it a heat map. How do you make a heat map? By uh, giving it a color, based on the density of numbers. Okay, so the red means sorry, the red means the pricing is too high. Blue means pricing is too low, and um, the and also the population of every area we were able to plot. So we were able to plot lo longitude versus latitude, then and the population as well as the median house value everywhere, along with the number of records being depicted by the density of values. So we are able to basically plot 5 variables on a single graph. Okay, so that's how. So then we hypothesized that the looks like the near to the sea has better ones, but then there are other values which are also near to the sea, but their values are low. Okay, and so then we talked about the correlation. Correlation is uh, basically correlation between data. If the actual value is increasing with the independent variable, the dependent variable is increasing with independent variable, then we call it positive correlation. If it is not not in a strong line, it's a high but not perfect. Okay, so if it is too much spread and it doesn't look like a line, then we call it a low correlation. And when it doesn't look like, it doesn't increase with this value, there is no correlation. Okay, correlation means something, there is a relationship between the two variables. Okay, if it is decreasing, we call it negative correlation, and that's what we talked about. So using the hist function, using the core function on the entire metric, entire housing data, we can quickly plot, we can quickly take a look at the list of, we can quickly take a look at the values on which say, so using correlation function, we can basically generate the correlation matrix. It will generate a correlation matrix with between each variable against every variable, right? And here, if we take a look at the median house value, we found that it is very much dependent on the median income. Okay, so it has a strong correlation between the median house value has a strong correlation with median income, because this one is one that means the variable itself has a strong relationship with itself. Okay, so and that is of course true. And median income, it has a good relationship with good correlation with the median income, because the number has come out very well. It's a quite useful function called core, which produces this. Okay, and the location, if you can see, the location is rarely rarely the longitude is hardly having any relationship with the median income, although there is slight relationship with the median income with latitude, but not with longitude. Now, okay, so let me just go back. So a question from Neera: for particular project, which algorithm we are using? We are going to use multiple algorithm. We are going to try multiple algorithms and then zero in on one, or those are the things that we need to do. Okay, because applying algorithm is probably the easiest thing to do, but um, exploring data and figuring out which algorithm to use is something important. Now, a question from Kamal. In the previous slide, the image exactly in the center, the horizontal line is not defined. Will it be +1, -1, or 0? Okay, so yeah, it'll be 0. Okay, a question from Mintao. Will we learn how to develop an algorithm or how to check and choose an algorithm for a specific data set today? So today we will learn about applying and choosing the algorithm. And as we go into the individual sessions, like regression, classification, then we will try to understand the reasoning behind an algorithm and how to tune and tweak it for our problem. Okay, good. Moving ahead. So in the similar way, we plotted the graph against every variable, and we were able to see that there's a correlation between the median income and the median house value. Okay, so why we call it median house value? Because every record in our data set is about a district, and the house value in that district is basically taken as the median value of all the houses. Okay, all right. So we learned that these two this variable median house value is dependent or is a has a good relation with median income. All right. So this is where we were till the last time. All right. So let's start. Wow, we have taken 40 minutes to do the recap. All right, let's try to make it smaller. Maybe tomorrow we will do it. Great, wonderful. So what we learned was the most promising attribute was median income. All right, and we we further zoomed in to see the correlation between median house value and median income by using the scatter plot, and we defined. I'll show you. Let me open my Jupyter. You can go to CloudX Lab, My Lab, and click on Jupyter. And in case you see this screen, start the server. Okay, what do we mean by attribute combination is basically we'll try to create combinations of attribute. Okay, you'll see that quickly. All right, and after this we'll talk about that. I need to refresh my dataset. Not dataset. I need to open a terminal and pull the notebooks. I'm opening a terminal, and there I'll just say cd ml. This is where I had pulled, git pull. Okay, so we have new data. All right, great. So let me just scroll down. All right, this is where we are. Okay. All right, so here we have tried to zoom in here by using the axis here, and basically we have shifted the axis a bit above and try to plot the data here. You can see the 52,000 and so on. And so we've said from 0 to 5 and from 0 to 50,000, 52,000 actually. That's what we have tried to draw here. Okay, basically selected the window such that so that we can take a look at just this amount of data. It's from here till here. Okay, so that's what we've tried to draw here. Okay, so what we see here is an interesting thing. We see there are the density of values is the house values look kind of capped here also, right? So that's what we are seeing here. Let me change it to different terminal. Yeah. All right. Now this is better. It's easier to sift between the windows. Okay. All right. Great. So what we learned was that that when we are right. So okay. And yes. So the question from Kamal is, how do we visually follow which cells are being executed? That I'm not sure, but if you are trying to figure out whether it has finished or not, generally asterisk here means that things are happening, as in there is something going on. So once you stop seeing the asterisk, then you will get the results. Okay, now there is something wrong here. Mm, okay, for me, it doesn't seem to have run. Till here, this is good. Okay. Okay, just a second. Okay, this is where we were. All right. Yeah. So you'll see asterisk here. If something is getting executed, you will see asterisk here. Okay. And yeah, that way you can always understand that it has finished or is still working. All right. So this is where we are. So we are trying to zoom in from, we are trying to see this value. Okay. All right. So yeah. So we understood that the median house value is increasing with median income, although it's not like a strong, very strong correlation. The whole thing is not uh, actually in the line. There is a spread, but still it's a strong correlation because it's increasing with it. Second, these horizontal lines are kind of, you know, mm, basically some wrong data or some data that is capped at various values. We need to remove that. Okay, we need to remove that in order to avoid the quicks, because this is kind of looks like a lot of data has been capped here. So we are trying to kind of aid our algorithm so that these the data that looks obviously the outlier, as in the something that is not really conducted properly or gathered properly, that one we can remove. Okay. And okay, so all right. A question from Gopi and Noor is, how do we know that if this data is not proper? So when we are trying to draw the whole graph, this scatter plot. So what we are observing is that there are these horizontal lines in the data. There are these horizontal lines in the data. Say, for example, there is this line, there's this line, and so on. Okay, we may choose to remove this kind of data in order to make our model a little bit more stronger. A question from Noor is, but that doesn't mean that the data gathered was wrong, right? It may not be wrong, but at points, what has been done to the data is the data has been capped at various points from time to time. As in, if you take a look at this one looks like a straight line and looks like that these values have been pushed down, may have been pushed up or down, and that's why it looks like a straight line at various points. Looks like a straight line. Okay, so when you look at this kind of, this looks very artificial. These straight lines look really artificial. Like the one here, this is artificial. Why? Because we have capped the data. Okay, right, right. So we will, for now, we will just try to see if we can remove this, but it's not really a hard and fast rule. This is just to support our model to become a really strong one, so that our model doesn't depend on this kind of data. Okay, so we can generally remove these kind of little bit outlier data. Okay, this is like manufactured or handcrafted, some part of it. Okay. All right. So again, the top line is also kind of capped. So what we'll do is either we will convert this top line into some form, as in we'll divide these numbers to something, or we will just remove the top line, one of these top lines. Okay. So this is also very handcrafted data, because the data points which were supposed to be above have been pushed down because it is capped. Okay. If you draw the histogram of median house value, you will see this. All right. So now, sometimes we do experiment with attribute combinations. Okay. And this one is something that we kind of depend upon our hunch or our knowledge of the problem. Okay. And this we can't really do in all kinds of projects. We can't really figure out that we can manually create the attribute combinations. Okay, but in case of housing, we know that the total number of rooms might have a relationship, but looks like here when we are seeing the total number of rooms, there is not much of a relationship with total number of rooms. But earlier when we draw the correlation, we found that total number of rooms was not really very useful, and but there could be a relationship between number of rooms per household. There could be a relationship between the number of rooms per household. Okay. And so what we do is, it's just our hunch that it could be there. So what we do is we try to see if our assumption or our hunch is right or wrong. Okay. So it's just one hunch, and it could be wrong or right. So what we do is we compute the total number of rooms, total number of bedrooms per room in this case. Okay, so what do we have in the data? We have total rooms and total bedrooms, as in this district, how many total rooms are there and how many total bedrooms are there. Okay, so could there be a relationship between number of rooms per household? Okay. Oh, sorry. There are there are multiple things. So we could divide the total bedrooms. Total number of. We can divide the total rooms by household. Okay. As well as we could try a combination called total rooms per bedroom. Okay. The okay. Let me go back. Okay. So a question from Gopi is regarding this one. So let me explain again. Question is, the next thing that we are going to do is we are going to experiment with the attribute combination. Okay. Our mileage will vary with each project. Okay. Meaning in some projects we are able to figure out this, some in the other projects we are not able to figure this out. So it is not really a situation where we can always get good results by attribute combinations. Okay. And it's largely a hunch. Okay. It's largely a hunch here, but we will learn further that using many techniques we can avoid this hunch and make it a generalized approach. Okay. And so here what we do is we are trying to create two more columns. One is One is number of rooms per household, okay, and other is number of bedrooms per room, okay, and population per household also seems to be a good, interesting attribute, okay. These are our hunch, okay. So what we do is we try to compute these three more variables. First one is rooms per household, other is bedrooms per room, and third one is population per household, okay. Meaning how many in that district, in each district, how many rooms are there per household, meaning total rooms divided by households. Then how many the ratio of bedroom to the total rooms. Okay. And yeah, room data is in square feet. Okay, here we are talking about the counts. Okay, but yes, it's I think in square feet. Okay. All right, let me go back here and try to show you this. Okay. Now, once we have this data, we have three more columns. This. Okay. Now, how do we find out the correlation? What we do is we again say house correlation here. We housing.cor function, that's what we are calling. And then we're just picking the column where the column with median house value. Basically, we are just trying to find out which all values are well correlated with the median house value. Okay, so you can see that here, median income definitely has a relationship. Rooms per household has some relationship. And in the negative side, because negative side is also a strong correlation, right? Here you can see that bedrooms per room has a better correlation than rooms per household. It's 0.25, right? Okay, which is basically, you can see that after median income, the second variable that has come out well is bedrooms per room. Okay, let me zoom it a bit. Okay, go ahead, Noor. Right. A question from Noor is, what does bedrooms per room means? Okay, so yeah, so this is an interesting thing. I'll explain to you. In a district, in a district, there are total number of rooms and there are total number of bedrooms. There are houses, there are houses which have bedrooms, and there are houses which have just the rooms. Okay, and in case, let's say there is a hotel, correct? Let's say there is a small hotel where every room is actually a bedroom, correct? Therefore, while in a normal house, generally um, the bedroom to rooms ratio is generally 1, that we have a living room, we have a bedroom, right? But in case of a hotel or in case of other places, it's the bedrooms are more than in case of hotels, or in case of say hostel or a shared places, the number of bedrooms could be more. Number of bedrooms could be more. How should I say? Um, let's say there are let's say there is how should I say? Yeah. So if let's say there's a hotel in which there are say 550 rooms, and let's say there's a hotel in which there are 550 bedrooms. Okay. And there could be, say, 10 more rooms. So number of bedrooms per room is really high in case of hotel, but in case of a house, normal house, generally the number of bedrooms and number of rooms are equal. This one you're talking about. All right. So yes, is this the one you're talking about? Okay. So question from Noor is that total rooms. Okay, let me just, I think I missed a couple of sentences. In that case, it is not better to make two subsets of data, one for commercial, one for residential. Bedrooms per room may not be meaningful. Yes. And we don't have that information about commercial and non-commercial in this data set. All right. So, or maybe some of the districts are more commercial than the others. Uh, okay. All right. So that we can see here. All right. So in this district, you can see that there are 1568 total rooms. And how many bedrooms are there? 351, right? While in this case, let's say this one, right? In this case, you can see that the ratio is not too high. I'll go down a bit. There will be more records. I'll just say 20. All right. So I think this will give you a little better picture. And yeah, that's why instead of we ourselves going over this ratio, we just computed this ratio. Yes. Thank you, Ross. So for commercial, the bedroom space will typically be closer to the total. That's right. And I think the best we can do based on this data is use this information, the ratio. So this one, let's say, yeah, let's take a look. Yeah, thank you. So 4861 looks more commercial because the ratio is like the looks like out of 551 rooms, the total bedrooms are 221. All right. So now once we have computed this, now the next thing we have to do is we need to use the core. Core function basically tries to do all of the relationship between all of these variables against each other, right? And there you can see that the housing value, the house value in an area depends on this value, this one as well, bedroom per room as well. Okay. The housing value looks like it is depending on the bedroom per room as well. Okay. And it's depending more, this is probably the second most important one. All right. Now let me plot this. So, all right. So basically we okay. So correlation means we are trying to find how well correlated one variable against another is. Okay. Basically the the scikit-learn gives us a very good function to quickly plot the relationship between each variable against every variable, as well as it gives the function to do this computation quickly, okay, this kind of computation quickly. Okay, to compute whether this is 1.9 or zero point 0.5, the core function does that. Okay, so it takes every variable against every other variable, tries to plot it internally, and then tries to find out how well it is having a correlation by trying to fit a line in it and then see if it is really, really well connected. So that's what it is doing for us. Okay, going ahead. Great. Our question is, what is the difference between household and population? The I think the population is, I think Gopi is right. Population is number of people in the district. Household is total number. Yes. Okay. Yeah. Total number of households as in number of houses. And Neerav's question is correlation meaning Cartesian product. Okay. No, actually, the correlation means yeah. I think Ross is right. So correlation means how well the two values are trending with each other. Okay, if you increase x, is y increasing along with it? That's correlation. How well these two values are related to each other. Okay, okay, and RMS is low between them. Yeah, you can say that. Basically, this is what it is trying to do. It's trying to fit the line and trying to find whether the root mean error is smaller or not. Okay, that's what it is trying to do internally. If it is like really low, really well fitting in a line, that means it's really well correlated. Okay, so -1 is basically, it's a negative correlation, but it's a good correlation. If you do the mod, then this will become 1. Okay, good. Thank you, Ross. All right. Did it make sense to you? Did it make sense to you, Neera? All right. Great. Moving ahead. So again, what we are trying to do is in the variables that we have just created, these three variables, we were trying to see how well our house value depending on these. And the way we do is we compute the entire matrix. If you take a look at it, if we just do this, okay, let me go up a bit. Yes. And let me just press A to create a new cell. And if I, okay, so if I just print this correlation matrix, all right, so you can see that it has tried to compute the value of longitude against longitude, okay, latitude against latitude, and so on. So it has tried to compute the correlation against all the variables, you can see. All right. And of course, this value and this value is going to be same. This value and this value is going to be same because it's a correlation between the two variables. These two variables are going to be same and these ones are going to be 1. Right? Why? Because it is comparing against itself. All right. So I hope this is clear. Now what we are saying is we just want to pick up the median house value column, the median house value. Where is the median house value? Here. So we just want to take a look at this one, and here it is. So here it is showing us the negative one means there is a negative correlation, but it is a strong correlation. So we could compute the mod and then do this. All right. So all right. So we could also, right. Okay. Okay. Question from Kamal is that he's not able to follow the steps. I think others might be having the similar problem. Is anybody else having the same problem? Are you able to follow it, or you have not yet tried? You must keep the Jupyter open. Okay. So go to this one and click on cell and run all above. Okay. Can I show the screen of Kamal and let him get up and running? Yes. I'll stop sharing my screen and you can go ahead, Kamal. Yes, go ahead. You can just click on sharing the screen and then I can take a look. Okay. Okay, good. Good. So one thing I would like to say is that open that what do you say? Yes. Um, Open a console as well. I would like to pull the fresh record. Okay. All right, great. That means we are all set. Okay, great. Now, let's say just refresh this whole thing. Refresh this screen. You can do that, yeah. Okay. Yeah. Now just go down. Let's go down. And where we are right now, we are down somewhere. Here. Just okay. Go down. I think we are far ahead. Okay, keep going, keep going, keep going, keep going. Yeah, here. That yeah. Yes. Just select the cell and this click on cell, run all above. All right, I think it is done. Go up a bit, go up a bit. Yes, it has go up a bit. I think it has finished executing. Yeah. Now try
What did you
any of
say?
it.
Just finished executing.
Otherwise it will show asterisk.
On which cell?
In there where it is showing 35, right?
Uh-huh.
There it shows asterisk when you execute something. Just try executing something. Shift enter.
No, it shows asterisks when I'm executing that cell, but when
Yeah.
I'm doing run all above,
Okay.
then it doesn't.
It does show. Okay. Okay. Maybe you're right. Okay.
So I'm actually clueless that what's happening right now when I'm doing run all above.
Run all above is yeah. It's not showing. It's doing it instantaneously.
Okay. So
Okay.
now what do I do?
I think yeah. Let's say go to say 71.
Okay.
71. Shift enter. Yeah. It has done that. Okay. It's doing really quickly. And yes, here the
I'm getting error.
it's giving a go up, go up. Is it doing anything? Go up. It has not created a column actually. Yeah. Do that 35 again. 35 again. Yeah, this one, shift enter. Yes. Now try those next ones. Yeah, try this one. Yeah, next one. It should work now. Oh, it again give the error. Go up this one. Yeah. All right. So basically those three columns were missing, and that's where the problem was. Okay. The Yeah.
Is can you hear me?
Yeah. Yeah.
My
I
question is
think
that did the run all above did not do that.
no, it did. It did. It did. I think it executed just above that one, and we did the cell that we selected was this one. Go up, go up, go up. I think this is the cell we selected, the 35th one. Just go up one more, one more. I think everything above this cell 72 got executed. Okay. And yeah, I think it's Ross's idea is also better. He's suggesting that we could we could just clear the cell output, and then you will see everything. You could say cell, you can click on cell, and current outputs clear. Okay, and then run it again from the beginning. Yeah. Oh, it did not clear. All right. All output you can say clear. Yeah. All right. So now you can run it again, and all right. Now you can see the asterisk. It's taking some time to do.
Does it mean that it is simultaneously executing all of them?
No, it won't execute simultaneously. It will do it sequentially, top
Okay.
down. Okay. It's
Now,
basically opening
where
the
am I now?
Python. Yeah, this is
Okay.
here.
So once the line number comes, it means it has executed it.
Yeah, otherwise it'll show asterisk. Actually, if you
Got
don't clear the output, it'll keep the previous line numbers. And yeah, so
okay, okay.
that's generally a bit confusing in the beginning.
Got it, got it.
Okay, so it is essentially opening a Python console in the backend, gathering all the cell values from top down, all the values which are code, not markdown, because you can mark each cell as well as a markdown as well. If you go to cell, you can mark the cell as markdown, right? So,
Yeah, got it. Yeah, I think I can follow now. You can continue.
okay, great, wonderful.
Yeah,
All
thank you.
right, yeah. All right, cool. So I was guessing that others would be having the similar problems. And I did have a similar teething issues when I started using the Jupyter Notebook earlier. Okay. Question from Abhinav, suggestion from Abhinav. Yes, it's really finishing quickly because we're not doing too much of intensive work. Yes. All right. And it is sequential, not parallel. Good. That's right. Now, we have our few variables which are really good, which are useful. So we're going to use these now. All right. So yes. All right. So this is what we discussed so far, and the total bedrooms has no relation. Total rooms has not much of a strong correlation, but bedrooms per room have some correlation. All right. Though it's negative, meaning as bedrooms per room are increasing, the median house value is decreasing. Negative means that. Negative means that. Negative means as bedrooms per room increase, the median house value decreases. Okay, that means the more congested or commercial place it is, the house value is decreasing. Okay, so the houses with lower the areas in which the houses there is a lower bedroom to room ratio are more expensive. Inverse of a mention, that's right. Okay, all right, good, good, good. So this is a little more, when you look at the data, you go with the hunch, you try to explore the data, you try to correlate various columns and attributes, and this is the kind of insights you will get in the data. All right. So this is kind of manual exploration, and these kind of things can also be achieved by other algorithmic techniques that we will study further, ensembling, combining variables, and so on. Okay, great. So this basically the idea so far is that you get used to your data. You get to know about the problem, the data that you are working on. And the steps so far are basically to make you comfortable with all kinds of churning. So if you feel like that you want to try these two attributes, you should not have inertia to try that, thinking that it'll take too much of time or too much of coding, because the data frame gives you this really, really good power to do things instantaneously instead of coding too much. All right. So now let's prepare the data for machine learning algorithms. Now, a very important thing that we would like to keep is whatever we do, we will keep on creating functions for it. Okay. You will see that as we create more functions, it's easier to pipeline them. Okay. Just like in Unix commands, those who have gone through the Unix pipelining, they will understand that it was far more. It is really, really very powerful to just create pipelines using the Unix commands because they can be chained together. Similarly, when we create functions, we will be able to chain the functions and call them and try various things. Okay, in and as we keep on creating more and more functions, we'll gradually build a library that we can reuse in our future projects. Okay, the whole scikit-learn library has been created this way by data scientists who have been trying to solve the problem exactly the way we are doing, like splitting the data and so on. They ended up creating scikit-learn in this way. Okay, a lot of functions keep on getting added gradually because of m- creating the because of tendency to create a function. Okay, so whenever needed, we will try to create functions instead of just writing the code. So though so far we have not created our own custom functions, but that's what we will do. Okay, and we were going to also, the advantage of creating the functions is that in our live production data, we can just change the data and do it. Okay, and creating the functions is useful because they can be used as transformations quickly. Okay, all right. So now, since we are going to work on stratified sample data, so we are going to copy the stratified training set and drop the target value, right? We would like to now work a focused way on the input data, the other variables other than our target value, which is, what is our target value? Quickly, what is our target value? Yes, the target value is the house value, right? That's what we are trying to predict. So there are dependent variable and independent variables. The dependent variable is our house value, while the other variables are the the independent variables. That's how we're looking at. So what we're going to do is we are going to drop the house value from our data set. Okay, and we're going to create another variable for that, mm, basically, so that we have input and output variables separately. And the drop function is not going to delete this column from here. It's just going to give us a new data set that we are marking as housing. Notice that housing was the actual variable also, the one which we started. So that's going to get overwritten here. Okay, and the yes, median house value is the price of the house. That is the output variable. This is input variable. Okay, so this is where we are separating our data. Okay, so yes, now we can take a look at this, and also there are a few more quirks with the data that we will have to fix now. Okay, let's do the data cleaning a bit. So let me show you what we have just done. Take a look at it. These two records. So housing labels are basically this is the median house values. Okay. So labels is something that we are targeting for our say any of our supervised algorithms will work on will this as the input variables. This is the target variables. Okay, these are the target variables, or we call them labels. Okay, so we have removed the housing value from here. Okay, the median house value, as in the price of the house, and we've kept it in another column, another frame. All right, so let me just delete this. Okay, so it is useful to know the shortcuts for Jupyter. You just have to either press escape or click here in order to go into the command mode. And if you say A means add a new cell, X means delete it. Okay, so a question: what is the block comment again? You can just press command and slash, command and slash. Okay, control and slash would be the would be in Windows. Yes, no, go ahead, please. Yes. So we are talking about this, right? Okay. Are you getting an error there? Okay. All right. All right. Okay. A question from Noor is that how can we say that it is correlated? Okay. So let me ask you this. What are the top two columns on which the median house value depends upon? Is well correlated. Top two on which house value is depending. Of course, it's depending on the self. Okay, income, and what is next? House value, of course, will depend on itself. So let's not count that. What are the other one? Second one? That's right. So it's not strongly correlated, but it is second best. Okay. So bedroom per room is something which is strongly correlated, is better than others. Actually, that's a better way to put it. Okay. It's not as strong as the income. Okay. Let me. Yeah. I think these doubts will be with everybody. So it's better to address them now. Yes. So it's essentially it's low correlation. I agree with that. It's a low negative correlation. Yeah. But it is better than others. So it comes in top two variables. Okay. So I agree that even the 0.25 is quite low correlated with respect to that, but it is better than the other variables. Okay. Good. Very good point. Very good point. All right. So where we were, good, good. All right. So this way we created these two parts separately. Now there are some more cleaning required. Let's try to clean up our data. And this is really important. And this is something, so now we have created two parts. One is left and one is right, as in the input and output. Now, some of the cells have missing values. Okay. When we say describe, the total number of values for total bedrooms are lower than the total number of entries. The total number of entries are 20,640, while the total bedrooms are only 20,433. That means there are 207 missing values, right? 207 missing values. So we will have to do something about it. So what do you suggest we should do about it? Anybody? So the algorithm would give an error saying the value is null, and it may not function correctly. So what should we do in these cases? For some of the records, total number of bedrooms were not provided. This data was not provided. Bintao suggests we should go with average. Okay, what else? Quickly. Gopi suggesting that we should replace na with 0. Okay. Okay. All right. So yes. Okay. Okay. So yes, those are the three options that you have come up with. So we could either get rid of the corresponding districts where total bedroom was missing. Second, get rid of the whole attribute. Get rid of the whole attribute entirely, as in the delete the column. The first one is delete the row, delete the column, or fill it with some value, either with the average or with 0 or median. Okay. And for that, we have these three functions. One is drop NA, drop, and fill NA. Okay. So we could say housing.isNull. Okay. So we could simply say, let's just take a look at these records where housing is null. Okay. And and we are saying that give us first records here. Okay. All right. So basically, this is where we are displaying the 5 records. Yeah. All right. So, okay, let me just break it down. I think that'll make more sense to you. All right. Let me break it down. So if I say housing is null, it's going to give us all the values where the values are null, right? All the records. Okay, and if I say any and we say axis equals 1, so we get only the first column, right? Okay, not axis 1. All right, so yeah, so you can see that these are the these are the values that are null, and if we are going to say axis equals 1, we are going to get values in the direction in the not in this direction axis is 1. Okay, and then we are saying axis equals 1. Okay, so we get in this direction. Then we are saying give us the records in housing for all the things where we are having true value. Okay, that's what is happening here. So it is basically listing all those records in which any of the values in this direction are null. Okay, so now let me just show you, instead of head, we can just put 100 and it'll show you 100 values. Okay, so it is showing us all the records where any of the value is null. All right, does it make sense to you? Yeah, in this direction, not this direction, meaning the vertical, not horizontal, you can say. Okay, now going ahead. Yeah. So what we can do is either we could just drop the entire column, entire right, entire entire rows, or we could delete the entire column with the drop. Okay, so we could say sample records and delete it and just check it. But a better idea is to fill it with something. Okay, so a better idea would be fill it with something. All right, so there is one more question. Question is from Gopi. If the district is commercial, it will not make sense to replace with mean. Also, if we delete the column, we'll lose a lot of information. Yes. Uh, and it makes more sense to either set 0 or drop those missing values. Okay. It doesn't make sense. Yes. It doesn't make sense to drop in our case because it's not the entire column is missing. Only few values are missing, right? Yes, any is a function. So yes. So instead of deleting it, in case let's say the values were largely missing and we could have used drop NA. And if we did not like the column at all, we could have just dropped the column. But here in our case, there are only few values missing, right? Values missing. So it's better to just fill them with something. So we can use fill NA, sets the missing value, and with what do we want to set it to? Median, not average. Okay, we're going to set it to median. As we discussed earlier, the median is a better representative because it's more stable. Just that the the computation that is required to compute median is higher. Who can tell me which one is more computationally intensive, median or average? Quickly, which one is more computationally intensive, median or average? Median, right? Why? Because you have to order the data. You have to order the data, and ordering the data is not a linear process, right? It is going to be n log n, as in if there are n records, the time it will take is not proportional to n, but n multiplied by logarithm of n. So median is requires sorting. Yes. All right. All right. So Kamal's question is, can you please repeat how to read the axis equals 1? Basically, axis equals 1 means we are looking at the data vertically, okay? And that's how we would like to pick the records, right? So we are going with vertical axis. All right. Okay. Should we take a break? Quick break. It's 8:43. We kind of forgot. And I'll answer these two questions after the break. All right, so I'm back. Should we start now? Okay, so there's a question from Binta. Let me answer that one, and then we can talk about it. All right. So first of all, this particular the statement is little complex. So let's just go back and try to understand it in a simple way. Okay. And the first question is, what does it mean by is null? Okay. First of all, what we are doing is we're calling is null, and on the result of is null, we're calling on any, and then we are passing that as argument to this one. Okay, as argument to this one. All right. So now let's take a look. So what does it mean? Is null means, let's take a look. What does it mean by is null? Is null essentially is, let me show you. So what is null show does is for the whole data frame, it it prints whether true or false for all the values. Okay, all the values, right? Whether if it's null, then it will mark it as true. If it is false, then it is not a null, then it is not null, then it will mark it as false. Okay. The other function that we let me just call it isn equals this. The other function that we talked about is isn.any. Let's take a look at the help. Okay, what does it mean? It means that, okay, it means that it returns whether any element is true over the requested access. Okay, over the requested access. Access here means access 1 represents columns and index means 1, right? So if we say, okay, is any axis equals 1, These are called keyworded arguments. So we're passing keyworded arguments to any function. So it is showing that this one is, these are all false, while this there would be somewhere which is true. Okay, so basically it's going to pick up only those records which have any of the values as true. Okay, any of the values as true. So here, that's why we are saying this. So it's going to apply this indexes on this housing. Okay, so it's going to pick up only the records where any of these values are empty or null. Okay, that's what it does. That's what it does here. And in our case, it's only total bedroom which contains any of the missing values. Therefore, it has picked up only those records, pick up those records where total bedroom is empty. Okay, does it make sense? So while isNull gave us the whole data frame, okay, any actually turned on based on each row. Okay, each of this, and that's how it is. And then we passed that as the index to housing, as in the argument to housing array, or the index to the housing array, and we got these records which contain any of the values as none. Okay, did it make sense to you now, Binta? Okay, great, great. Now there was a few more questions. Let me answer. These are very important questions. Yes, Kamal's question was, is there a way to synchronize the line numbers in Algebra Notebook? I think that's something I'm also finding it hard. And if you get a solution to that, it'll be great. Because what we do is we have the GitHub repository, which has some line numbers. And when I run it, the numbers are, unless I run something new, it'll have the older numbers. And as soon as I run, it gets a newer number. So there's always there's no way to kind of give a row number or a row ID or a position or the anchor in the page. Okay. The better way to do it, just try to search something like this in the page, and then you can find it. Now, a question from Ross is, have you used imputer class? That's what we're going to use. Good point. Okay. All right. Okay. 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 So, all right, let me try to make sure that all of you get a Python for machine learning certificate as soon as you finish the project. Okay, that's a question from Vidya. Now, okay, go ahead, Noor. Okay, a question from Noor is, don't you see we are missing an attribute, number of houses or number of dwellings in a data set? Yeah, you are right. The households is actually that number of household. Okay, number of households is that. Great, great. Wonderful set of questions moving ahead. Now, so what we're trying to do is, okay, so now here is the question. Question is, should we fill it with median or zero? Okay, if we fill it with zero, we are explicitly setting the value to be zero. right? That means it could force our model to be biased, right? It could force our model to, um, you know, change that. Okay, the value before this was something, after this was something, and suddenly in the midway it is zero. Therefore, the chance of error in our model will increase if we set the missing values to zero. Okay, chance of error will become the good. All right. So here the easy one way of filling it with something is, first we compute median. We say housing total bedroom median, and then we say here we are just running it on our sample records, and we say total bedrooms dot fill NA median in place equals to true. Okay, in place means we don't have to assign it. Instead, it will modify the actual records. Okay, so here we are saying compute the median for this particular column, and then we are saying sample rows, the one that we computed earlier, fill in with median. So once we do that, sample this variable is set to the median of total bedrooms, right? All of these have, instead of NA, they have become, instead of NaN, not a number, instead of that, it has become 433. All right, but good news is that scikit-learn provides us with this wonderful class called imputer. Okay, all right, so yes. All right, scikit-learn provides us with imputer class to take care of missing values and create so all we have to do is instantiate, meaning create an object of imputer class and specify each attribute's missing value. Okay, and we should just tell that it should be replaced with what. Okay, so while creating the imputer class, we define the strategy. Here we are saying strategy is median, meaning when we apply this imputer object, it would replace it with median. Okay, and remember that this is going to be part of our pipeline, and this is the first step in pipeline, that we define a class and we create this object so that it's not only us, but somebody else, like a pipeline, could also execute it whenever needed. So we could chain them together. Okay, so that's why it's generally better to have this kind of model. Okay, so we are defining our strategy, and then we are applying that. But before going ahead, we know that there is one categorical variable whose values are numerical. Okay, whose values are not numerical. So ocean proximity is not numeric. So it's basically a categorical variable, right? So we'll learn how to convert this categorical variable into the numerical one, and and we, for now, we can just delete this. We are deleting the this particular column from the housing data set and defining a new data frame. Well, let's call it data frame, not data set. Defining a new data frame without this particular column. Okay, so imputer is essentially a class which will help us fill the missing values. Okay, and with the imputer, once we have instantiated imputer with our strategy, the next thing we can do is we can fit the data frame having only numeric attribute. Okay, and once we are done with that, then we call the other method. So first method is fit. Fit means it's going to be executing the value, the imputer on this with the strategy, and do the necessary calculation like computing median. This is where the median is being computed. Okay, this is where the median is being computed. Yes. So imputer is going to apply on all the columns. Okay, so what the fit method does is, imputer's fit method basically computes the median of every attribute and stores the computed median in statistics instance variable. Okay, that's what it does. It basically computes everything and puts in member variable called statistics underscore. Okay, so and once we are done with fitting it, then we can transform the actual data. So there are two steps process. First is three steps actually: defining the class. Let me zoom it a bit. Okay, I hope it's visible to you. So, okay. So it's going to, first of all, we are importing this imputer class from the scikit-learn pre-processing, then defining an instance of it. Okay. Did I? Okay. All right. So let me also do that. Okay. And also remove this. Good. So we are first of all calling this fit. Okay. It has computed all the medians that are required. And when we say statistics, statistics is what it has gathered. What it has gathered. Remember for 433, this is the median of that total, that particular column that we want to fill in. Next thing we are going to do is we are going to call transform on housing number. Okay, what does transform do? Okay, okay, all right. So transform basically fills in with these median values for each column. That's all. Okay, so here we are. A question from Kamal. Don't worry, actually, the sample incomplete rows are not going to be used anyway. Okay, so even if you can just recompute the sample incomplete rows just 3-4 cells before. Okay, so you can just find that out and just recompute it, just like maybe 10 more cells. That's all. Okay, you can just keep on pressing Shift Enter. It keeps moving from top down. All right, now this is how it is happening. So it's straight, really straight. So imputer class, basically the standard way with all our algorithm is going to be instantiate, fit, and transform. Instantiate, fit, and transform. That's the general mechanism. And since most of the methods have the same fit, I mean instantiate, fit, and transform, we can hand over all of these all of these objects to a pipeline so that they can be executed. Okay, so these are really seamless way of filling in the values with the median. Okay, now since X is basically a NumPy array, X is a NumPy array, we are going to create a data frame back out of X. Okay, by specifying the columns using our original data frames columns. Okay, so now housing TR as in truncated one or transformed one, housing TR is having the value for that particular, as in if I say 200, so it should be having 433 for total bedrooms at many places. Okay, probably. Okay, so there are no null values and it is fixed. Okay, and also we can just do a describe here and then take a look at how many describe. Describe will tell you how many values are there. Okay, and not this one. No. Okay, yeah. Info is giving us that value, so it's showing that there are 16,512 entries in this. I'm just wondering what happened to the other entries. Anybody has an idea? There was supposed to be the total. Oh, we did that. We splitted the data into 20%, 80%, right? So that's fine. Because 80% of 20,000 is 1,600. Okay, so yeah. So now the total one is still wrong actually. The okay. Now this is correct. You see that? Okay, housing TR info is giving all the records equal. That means our imputer has worked well. Okay. All right. Now is the next step. Okay, this is what we did in order to because imputer gives us a numpy array, and therefore we needed to convert this numpy array by into data frame by specifying the columns in the constructor of the data frame method. Okay, so we are saying pd.dataframe and passing the numpy array, passing the columns, and that's all. All right. Great. This looks clean. Now, question to all of you is, in the training set, only total bedroom attribute was having missing values. Why did we transform the entire data set? Yes, I know. Okay. All right. Right. So the correct answer is yes. So the thing is, maybe today, this particular data set in this sample, we don't have other columns value missing. But in future, since it's going to be a model, it's going to be a pipeline, we need to make sure that whatever we do, it should work in all possible scenarios. And therefore we use we use it, since we are going to use it as pipeline, and we're planning for our, let's say, in the production or reruns of the same one, or in case of other data sets, it's useful to be there. Okay, right? So as new data may have missing values when system go live, right? Okay, a question from Gopi. Is there a way to show labels on imputer? A good question. A good question. Is there a okay? Is there a question? Is there a way to take a look at the statistics columns? Answer is no, because most of the calculation which scikit-learn is going to do is based on the NumPy. NumPy is highly efficient, and the scikit-learn is going to do most of the heavyweight lifting on NumPy. The data frame is for the convenience, for the representation of all kinds of data. So whenever there is going to be a number-based calculation, we're going to use NumPy. All right. Okay. Now, moving ahead. So yes, so you can take a look at this URL which Ross has said. I think you can just say help and just pass the imputer instance. You will get the yeah. Okay. All right, moving ahead. So now the next thing is handling text and categorical attributes. It's another very important one. All right, great. So All right, great. Now moving ahead. So I'm not sure in the Jupyter if you can take a look at I mean, the general way would be just search for the class on online, and that's generally a better way. Okay, because Jupyter is nothing but basically a wrapper around Python. It's calling the Python, and whatever Python displayed there, it just shows that. Okay, and yeah. All right, great. Now moving ahead, and the very important aspect of the whole model is what to do with the categorical attributes. What to do? What should we do with this categorical attribute? The one way is that i- okay. So what is the categorical attributes? Categorical attributes is the ocean proximity. Okay, ocean proximity, and let me just show you all of these. Okay, and so when we take a look at this column called ocean proximity, it looks like uh, lesser than 1 h ocean. It's a string. Okay, it generally I think it means that within 1 hour from ocean, near ocean, island, in the land, within 1 hour in the land, and so on, right? So this is where we use something called Factorize. Okay, so what Factorize does is Factorize converts the categories into numbers. Okay, because most of the computation is easier on numbers, therefore we need to convert most of the categorical attributes into numbers. Okay, so what we do is we basically say take a column from data frame and say factorize. So what it does is it gives the name to them. So this is 0, 1, 1, 2, 0. Sorry, 0, 1, 1, 2, 0. Right. Sorry, this one is going to be not 3, it's going to be, oh yeah, it's going to be 3 because type 0. So because it's type 1 but 0. So this is how it is. Okay, factorize basically gives them numeric values going from left to right or top to down and assigning them numbers. If it's a new one, then it basically creates a next number. Otherwise, it just repeats the previous one. The logic is very similar to the word count problem. Okay, now, so what this is what we're doing. So here the housing we can convert this into numeric attributes so easily. Okay, all right. So let me go back here and show you here. Okay. So the factorize method basically returns two things. It's a tuple that it returns. One is the translated values, and other is a list of the labels. Okay, other is the list of labels. So that's what it returns, and so that's what we have done here. We have said housing categories dot factorize. We assign it to two variables. This one contains the array having the numerical attributes corresponding to the categories. Okay, and the housing categories contains the labels. Okay, all right, let me go up, try. Okay, all right. So then this one encoding is pretty simple. Here, all it is doing is going from left to right. This one is given 0, this one is given 1, this one is given 1 because it's the same one which we have encountered. And then this one is given 2, this one is given 3, right? I hope that's clear to you. So this is pretty simple, but basically we are just giving them numbers starting from 0 to onwards. All right. So All right. I hope this is clear to everyone by how we have given them the numbers. This also means that we are going to end up with awkward sequences. Remember in the categorical one, we had ordinal categories where there was high, low, medium, and the numbers that we get may not be in the same way, right? So sometimes you might get 0 for high, medium is say high, 0 is high, low is 1, and medium is 2. That kind of thing could happen. That's what we are trying to demonstrate here. That that all it does is goes from left to right, gives them the numbers starting from 0, right? So that's why we generally use another kind of method. Okay, another kind of method. Okay, to fix this kind of problem, what we use is we use something called one hot encoding. One hot encoding. Okay, so what we do is we break down a category into multiple columns. We break down a category into multiple columns and we mark them true or false based on whether which value it is. Okay, so so for example, one attribute will become is lesser than one H ocean. This will become one column. It'll be one if this is true, otherwise it'll be 0. Similarly, for inland, it'll be 1, otherwise it'll be 0. So I'll show you. Let's take another example here. So there is a company called VW, Acura, Honda, and these are the categorical values. Okay, let's ignore this for time being. Okay, if we convert this data into our usual mechanism, it'll become like 1, 2, 3, right? But if we convert this into a hot encoding, the one hot encoding, what it will do is it will convert this into 3 columns: VW, Acura, and Honda. Okay, for VW, it'll mark it as 1. This is tick. Since it's not Acura, it's not Honda, it's 0. Okay, and then 20,000, right? So, so what we did was we broke down a column into so many columns. We converted it into 3 columns. All right, this is called hot encoding. One hot encoding. Why one hot encoding? Because there the cells which we are marked as one, that is called hot and rest are cold. Okay, and this is going to be a very sparse matrix because for each row only one of the cells, either this or this, only one of them is going to be an true. Only one of them is going to be true. Other else will be false, as in 0. All right. A question from Gopi. Sorry, a few slides earlier. How come we have multiple type 3 attributes? There could be multiple type 3, right? It's just data. Okay. A question from Nirav. Could you explain this again? All right. So imagine that, right? Let's just ignore this second one. Okay. And all right. Okay. I see. The annotate works. Okay. Let me just try. Okay. So, okay. So if we have, okay, I think I can draw on this as well. Okay. Okay. Let me clear this annotation, then we'll try again. Okay, here we go. Okay, so let me just explain. So imagine that, okay, let's just try to draw a simple two-column matrix. Okay, and okay, never mind. So here we go. So let's say one means, let's say one, and the ID is high. Sorry, the value is high. Two, value is low. Three, me value is medium. Okay, and maybe but four values again low. Let's say there are four records having these four values. Okay, and let's say this is ID and this is some value. Correct. So since we most of the algorithms work on numbers, so we need to convert this into number. One way is just assign them some value. Start from top, give it 0, 1, 2, 3, and so on. Okay, or maybe we do this operation ourselves. We convert them into numbers by saying high equals 1, low equals 2, or medium equals to 3, or something like that, right? But this one is not very general. If we do it manually and ourselves, that's not very general. So the way we do is we use the hot encoding. And how does the hot encoding work? It's going to give it convert this into three columns. Okay, it is going to convert this into three columns, as in like this. Is there a better way to create a three column than this one? Okay, let me just try with this one. Okay, so it's going to break it down into first, second, third. I think that's it. Yeah, and okay, so it's going to give this as a name. Wow. Okay, this is going to be high. Is there a better tool for doing the high, low, and medium, right? Okay, and this is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4. Okay, and so it's going to be, since 1 is high, right? So it'll be 0, 1, it'll be all of others will be 0. Okay, and then 2 is low, so we are going to say 1, sorry, 0, and 1, and 0. Okay, 3 is how much? Medium, right? So it's going to be 0. This is going to become 1, and this will become 0, right? So what we do is we, for each of these values here, all of the unique values of the categories will become columns, and we'll mark that particular column as 1 where the value is matching. So first becomes this, and second becomes this, and so on. All right, and this one becomes somebody help me. This become 1 and 0. Okay, so this is how the one hot on encoding works. All right, it's like an XOR of for all category. You can say that, yes. That's right. Thank you, Kamal. So if we use Factorize, whereby we are just giving the arbitrary values, like here we are giving 1 to this, Acura is 2, Honda is 3. So we might end up assuming that Honda is bigger than Acura because Honda is 3 and Acura is 2. So that's a downside of using the categorical value. Okay, yes. All right. Now, this was the manual example. So basically, good news is that Scikit-learn provides something called one-hot encoder, which converts this into integer categorical values, and basically this is what it does. Okay, so all we do is again we do one-hot encoder, then do fit and transform. Also, fit transform does the two things in a single shot. All right, so. Okay, all right, so never mind. Let me go up. Where are we? All right, so using one hot encoder, we can do that. Okay, our question is, what does statistics do? Statistics basically print the median values of that imputer, right? Because it must have done the calculations. Okay, all right, is everybody able to do this? Are you able to run this? Okay. Also, please note that we are doing the one hot encoding of the array that we got it earlier. Okay. You could do the same thing of the housing category as well. Okay. Since housing category this is a one-dimensional array, we might have to reshape it into two-dimensional. All right. That's the reshape -1, 1 doing. Okay. So, so if you have an array with a single dimension and you would like to convert that into um, two-dimensional array such that there is only single column, then you can use reshape. Reshape -1, 1. Okay, this is a sparse array. Why? Because you see, all these values are 0, 1. Sorry, all these values are empty. So we could fill in the values like one, or other one, or so on. So with let me go back. Let me explain. Okay, so sparse array is one in which not all values are filled, while dense array is one in which almost all of values are full. Okay, so here we are, and yes. All right, so good. Everybody's okay with this? All right. Now, now, the next step would be to combine the two, combine the text categories to the integer. And so, so first was we converted the text categories into integer categories by using the factorize, and then we converted the factorized one into one hot vectors, right? So what we can do is we can create our own categorical encoder, okay? Or we can define our own method to do that, right? Or there is already, this one is already there, okay, here, yeah. Let me go up, let me go up, yeah, okay. So here, what we have done is, in this class, what we have done is, we have tried to define our categorical encoder. This categorical encoder basically combines the two, okay? It combines the process of transforming text categories into integer and integer categories into one hot vector. And we have created our own custom transformer or encoder, okay? And yeah, and this is going to be in the future releases of the scikit-learn, probably the combining of the two. And this is how it is defined, okay? So again, the sole objective is to build an entire pipeline. So here what we're doing is we are defining this class called categorical encoder. This one, the one which we have above used above, and we are saying, um, basically we are shaping the categories values into two-dimensional using this, and then calling the fit transform on top of it, so that we get the resulting attributes, resulting resulting data frame having both values. Okay, all right. Let me again explain what I mean actually. Yeah. All right. So okay, so there were two steps involved earlier. One was converting text categories into integer using factorize. Second was using the technique from using the numerical values into one hot vector. Then we basically use, instead of doing it manually or calling them as a function, as we discussed earlier, will be creating our own functions or a pipeline for the pipeline. So we created our categorical encoder. Probably they will, scikit-learn will include in there. It's, I think, in the pending commits. Now, so this is the process which does the both steps in a single shot. Okay. All right. Now, next, moving ahead, can we use multi-label binarizer for this? I'm not sure. I'll have to take a look at that. All right. Now, coming back to it. So now, now we can uh, we can also create our custom transformer tasks, such as for cleaning up operations or combining specific attributes. And scikit-learn pipeline, this class helps us in defining and executing sequence of transformations. We can we can define our own transformers, and we can call our own transformers using pipeline. So remember that what we did earlier in the whole exercise, we did many operations, and some of the important operations were splitting the data, then doing the stratified sampling, right? And next was doing stratified sampling. Next was combining attributes, right? So maybe we can create our own class to combine multiple attributes, right? With the way we created three more columns, right? And using those three more columns, we were doing the rest of the computation. So all we have to do is we can create a class, implement these three methods, fit transform and fit transform, fit underscore transform. Okay, and I'll show you this part. So basically, we can we'll have to, while we are defining our class, we'll have to inherit the transformer mixin as the base class. Okay, and so let's create a custom transformer for creating these two more attributes. Okay, so rooms per household and population per household. So we are going to create co combine attribute adder class. It's really simple. It's really simple here. You see that? So we are defining our own class called combined attribute adder. Whenever you're creating your own transformer, you generally inherit some class. So these are the two classes that you are inheriting. So your combined attribute adder is inheriting base estimator and transformer mixin. If you inherit this one, then we don't need to implement fit underscore transform separately. Okay, it will implement it for us. Why? Because fit underscore transform is nothing but this combined with this. Okay, so yes. So on every object, we generally end up calling once fit and then transform. But in the pipeline, in the production, we would like to just call both of them in a single shot. Therefore, we if we generally had to define three methods: fit, transform, and then fit underscore transform. So to avoid the third method, we just use this base class, which internally is providing fit underscore transform for us. Okay, so here, what we're doing is we are instantiating. Init means the constructor. So here we are saying that this is this self is a method which points to the current object, and here we are saying that we are defining a keyworded argument. So we are saying add bedrooms per room equals true. So this is the argument that we are getting in the constructor, and then we are setting it. So here, this is the default value for this. If the user, while calling our combine attribute adder, does not provide this argument, we are going to assume its value as true. Okay. If somebody explicitly defines it as false, then we'll set it as false. Okay. Now, fit doesn't have anything to do in our case. While what we are doing in transform is we are creating these columns. We are saying rooms per household is equals to this, and population per household is equal to this, right? And then we are saying if this is true, add bedrooms per room equals true, then do this. Otherwise, just return the base. Okay, so that's what we are doing here. All right, so that's what we are doing here. We basically are trying to show that whatever step we need in our pipeline, whatever steps we have done so far, we can similarly create these transformers for those steps. Here these three attributes that we created earlier, rooms per household, population per household, and bedroom per room, these are the attributes that we are adding into our array. This is NumPy array, by the way, and yes, okay. So when we want to use this, all we have to do is instantiate it. This is where we are creating an instance of combined attribute adder. This is the instance of it, and then we are calling transform on it. Okay, There's no need of fit, and we just are calling transform, and whatever output we get, we're converting that into a data frame. Okay, did it make sense to you? So the steps that we did earlier for creating these three columns, we just defined a class for doing the same thing. And to define the class, the only thing you have to remember is class followed by the name of the class, and then these two base class to inherit. And then this is your, if you want some extra attribute, you can put that here, or you just leave it as such. Okay. Then the next thing you do is, maybe if you need, then define fit, or you define transform. Okay. And you define transform. So you need to define these two methods, fit and transform. Okay. You can choose to do nothing. Okay. All right. I hope that's clear to you. So that we can hand over this to scikit-learn and in the pipeline, so that our piece can become a pipeline, a thing in pipeline. All right. So that's how generally the way it is going to be. Your model is going to sit in midway of the pipeline, and your model itself is going to be a kind of pipeline. The training of it is going to be a pipeline. All right. Okay, a question from Gopi. So the third last line is to impute values, and second last line is where the additional columns are being added. Third last line are, where are we doing impute? Let me just take a look. Here, do you mean this? No, actually, this is calling our method. This is calling our method, right? So this is attribute adder is the instance of this class. And when we are calling transform, it's calling this method. And this method is defining these three more columns. Okay. Question is that how to check a attribute, a function of a class with help. Okay, let me show you what it means. So let's say you want to know what it means by this, right? So you create an instance of this class and say help here. You can say help and call this. Okay, this is what you mean, Binta. You can say help and this. Object.class method. All right, let's move ahead. I think this is good. So we just learned that how to create your custom pipeline. And this is generally your, as a data scientist, you will end up creating your own pipeline, as in the transformers or the encoders, which will be used in the pipeline. Okay. So we just learned how to. Okay. Okay. So we just define our method, and now the next important aspect is the feature scaling. Okay. If we observe the housing data set once more, we'll find that the total number of the total number of rooms ranges from 6 to 39,000, right? While the median income only ranges from 0 to 15. So it's actually a problem because the machine learning algorithm do not perform well when the input numerical values have very different scales. Okay, when the input numerical values having really huge difference in the scales, we might have to come up with something to bring down the attributes into that can fit the scale. Okay, so the solution is, can you guess what will be the solution to do this? Normalization, good. Other than normalization, what else can you do? Okay, so one is scaling, as in divide by some constant, or normalization. All right. So right. So one is we can bring the ranges with the median values. Yes. Right. So we can do that also. So there are two general ways of scaling. One is min-max scaling and other is standardization or normalization. Standardization we will see as we go ahead. And so normalization is min-max scaling or normalization is the same thing. The way we do is we basically pull the leftmost value to 0, okay, and the rightmost value to 1, and everything in between. Okay, let's say this is your data and you would like to convert it into something 0 to 1. That's what is min-max scaling is. We basically pull the left hand side to 0, right hand side to 1, and everything in between. So it's like if you think of it like an elastic line, and we basically take the left hand side to the 0, right hand side to 1, and everything in between. And how to do it numerically? We basically find out what is the maximum, what is the minimum, and then we find out the range, max minus min. So the total length of line we know now is 200, and each value is subtracted from the min. Okay, so this is subtracted from the min, all right, divided by the range. Okay, divided by the range. So minus 100 minus minus 100 is 0, divide by whatever is 0. And if minus 50, minus 50 minus 100, that is plus 50, divided by 200 becomes 50 divided by 200 is how much? 0.25, right? Somewhere here. And 0 will become something like 100 divided by 100 divided by 200, right? So it'll be like 0.5. So this is called normalization. This is clear, right? The formula is clear. So all we did was we took this left hand side to 0, right hand side to 1, and everything in between. Okay. So this is an example of min-max scaling. So we have defined S1 and S2, created a data frame with two columns, S1 and S2, and then we are, from the pre-processing of ML extend, we are importing min-max scaling and then calling this method called min-max scaling on the data frame with these two columns. And then it automatically does the min-max scaling for us. Okay. The other form of feature scaling is standardization. We handle various types of data like audio signals, and because so here this is good. This is good for many cases where the data looks very linear, right? If the data is varying humongously, is going from 0 to a million, or something like if the data is too dense on one side and too sparse on one side, what would happen is this would end up being something like 0, 0.001, 0.002, 0.003, 1.8, 0.1. So for some of the ranges, this data might become so really dense, and therefore this data may not, this scaling may not work in all cases. So this is where the standardization comes into play. Okay, so in the cases where all kinds of data is there, you end up with either too dense data, which is there are many values on the change of a very small number. Okay, while there are very few values on the other side. So in that cases, what we do is we do the feature scaling using standardization. Okay, it's pretty simple. The way we learned earlier, like the way we compared the scores of Pam and Jim, in the same way, we basically compute how far is every number away from the mean. Right? So this basically makes it more sense, right? All right. So all we do is first compute the standard deviation for the whole data set. Okay. Then the standardized value is subtract the value from the average, divide by the standard deviation, right? So we can simply say that we basically convert each number into a fraction, or into uh, into a number, as in into another number, which signifies how many standard deviation is a number away from the center. How many standard deviation away a number is from its standard deviation. Okay, so is this formula clear to everybody? So question from Kamal is, what if it is not a good ND data? ND as in n-dimensional data or normalized data? No, even if it's not normalized distribution, it will still work. Okay, because it's very clear that number of standard deviation something is going to be away is going to be very small. It is still okay if it has two models, right? That's what you mean. It's bimodal. Yeah. Even then it is completely okay. All right. Okay. So in this standardization, features are rescaled so that output will have the properties of standard normal distribution with zero mean, okay, and unit variance, okay, unit variance. So, okay, so basically it will push the data to be such that the data is going to be, there won't be too many values beyond a certain numbers. And you will notice that what standardization does is standardization makes kind of converts the numbers into a bell shaped. Okay, and you should notice that part. Okay, and because there will be only few values, the way standard deviation is computed based on how varying is the data. If the data is too much varying, the standard deviation is going to be really high, right? Standard deviation is going to be really high, and therefore when you divide something by standard deviation, it's going to bring that value down, correct? So standard deviation is going to be high if the values are varying very much. It's going to be low if it's varying really less, right? So, and when you are subtracting something from mean and dividing by standard deviation, if there is a huge the value is really high or really low, standard deviation will try to bring it down. Okay, try to bring it down, and therefore, it will try to push the outlier towards the center. That's right, Gopi. All right. So yes. So standard scalar, as Ross was suggesting, is used here. So that's correct, Rosh. This is exactly for the scenarios where the data is very much skewed. Okay, data is very much skewed, and like in the case of a linear scalar, where we were doing min-max scalar, there the problem was that the if the data is really skewed, we are going to get bad values. So here in standard scalar, it's going to do a good job with skewed data. All right. So the only downside of standardization is that it it does not bound values to specific range. Okay, it does not bound or force the data to be of specific range, right? And and that could be a problem with some of the algorithms. There could be one or two outliers which are, even after dividing by standard deviation, they might still be far away from the mean, right? That could be that could be problem. Like, so that's the only case. That's the only thing, only problem with the standardization. Other than that, standardization works pretty well. Okay, though min max forces the data to be within 0 and 1. Okay, so in case of neural networks, say there are many algorithms which are strictly for 0 and 1, within a range of 0 and 1. In those cases, the standardization may not work. Yes. Yes. So Kamal is suggesting we could standardize and then apply min-max. Yes, we could do that. We will also learn few more functions later on. Okay. We'll learn few more functions. There are few more functions which can be used for linear scaling. If your data is exponentially growing, then you might want to take a logarithm of it, or you might want to use the other functions that we will see in future, in order to bring down your data strictly within the range of 0 and 1. Okay. Now, the pipeline is what I wanted to show you. Okay. All right. Okay. Never mind. So yes, I, I think this is the only project which is taking time, and I think after this it'll be easier for all of us to move fast. Okay. Great, great. So we'll complete the end-to-end project tomorrow. All right. So we'll start from the pipelines tomorrow. Okay. All right. All right. And tomorrow I'll be, giving, forming groups of 2 and then giving the project. And while the rest of the course is being done, you can start working on the project right away, right after this. All right. So thank you, everyone. And yeah, I look forward to see you tomorrow. Thank you, Abhinav. Thank you, Balaji. Thank you, Bintao. Thank you, Gigi. Thank you, Gopi, Kamal, Neerav, Noor, Pratik, Ross, and Shahrukh. I look forward to see you tomorrow. All right. Keep questioning, keep asking questions. That's the only way to learn. Bye bye. Have a good day. All right. Bye, Ross.